So in this problem, we have an arithmetic progression. So in this arithmetic progression, there are 4 terms that has been chosen: the P8, Q8, R8 and S8 terms. Now these 4 terms are in geometric progression. So using this information, we need to show that P minus Q, Q minus R and R minus S, these 3 terms are in geometric progression. So let's begin. First, we'll specify the first term and the common difference. So let A be the first term and D be the common difference. So now let's first define the terms. So the P8 term, AP, that will be given by A plus P minus 1 times the common difference D, because those terms are in arithmetic progression. The Q8 term, that will be equals to A plus Q minus 1 times the common difference D. Then we have the R8 term, AR, that will be equals to A plus R minus 1 times the common difference D. And we have the S8 term, so that's A plus S minus 1 times the common difference D. Here it's given that these 4 terms, the P8 term, the Q8 term, the R8 term and the S8 term, these 4 terms are in a geometric progression. So that would mean that AQ divided by AP, so we're dividing the second term by the first term. This must be equals to the third term divided by the second term, which is equals to the fourth term divided by the third term. So this is a condition for 4 numbers to be in a geometric progression. So let's label each of the equations. So let this be equation 1, this will be 2, and we have equation number 3, equation number 4, and we'll be using this condition a little while later. So this is number 5. Now what we'll do, we will subtract equation 2 from equation 1. So let's do 1 minus 2. So this is going to give us AP minus AQ. So this will be equals to P minus Q times the common difference D. Then if we do 2 minus 3, that means we're going to get AQ minus AR. So that will be equals to Q minus R times the common difference D. And then we're going to do 3 minus 4, which is going to give us AR minus AS, which will be equals to R minus S multiplied to the common difference D. So we're going to label these 3 equations as equation number 6, 7 and 8. Fine. Now using equation number 5, now from equation number 5, so let's choose AQ divided by AP, that's equals to AR divided by AQ. Now what we'll do, we'll subtract 1 from both sides. So we have AQ over AP minus 1, that's equals the R8 term divided by the Q8 term minus 1. So let's compute them. So we're going to get AQ, so that's the Q8 term minus the P8 term divided by the P8 term, which is equals to the R8 term minus the Q8 term divided by the Q8 term. Fine. This can be now also rewritten as a Q8 term minus the P8 term divided by the R8 term minus the Q8 term, which will be equals to the P8 term divided by the Q8 term. So if we multiply both the numerator and the denominator by -1, so we'll have the P8 term minus the Q8 term divided by the Q8 term minus the R8 term. So this will be equals to the P8 term divided by the Q8 term. Now using equation number 6 and equation number 7, so we can replace the P8 term minus the Q8 term with the value P minus Q multiplied to the common difference D divided by Q minus R times the common difference D. So this is equals to the P8 term over the Q8 term. So we can cancel out the D. So this is going to give us P minus Q divided by Q minus R. So this is the P8 term divided by the Q8 term. We'll take the reciprocal and rewrite the equation as the Q8 term divided by the P8 term. That will be simply equals to Q minus R divided by P minus Q. So we have one set of the ratio. Next, what we'll do, we'll use the other ratio. So we'll use the second and the third ratio. Again from equation number 5. Again from equation number 5, we have the R8 term divided by the Q8 term. So that's equals to the S8 term divided by the R8 term. So that means we now have Now we're going to subtract 1 from both sides. So we have the AR minus a qt term divided by the qt term. That's equals to the asset term minus the arith term divided by the arith term. Rearranging, we have AR minus AQ divided by AS minus AR, which will be equals to AQ over AR. We'll multiply both numerator and the denominator on the left hand side with -1. So we have AQ minus AR divided by AR minus AS, which will be equals to AQth divided by ARth term. We can take the reciprocal right away. So we have the arith term minus the asset term divided by the qth term minus the arith term. So this will be equals to the arith term over the qth term. Now we can use equation number 7 and 8. So the arith term minus the asset term, so that's simply r minus s multiplied to the common difference d divided by q minus r times the common difference d. So that's equals to the arith term divided by the qth term. So here d and d cancels out, and we can rewrite the equation as the arith term divided by the qth term. So that's equals to r minus s divided by q minus r. Now we have already shown that this ratio, the qth term over the pth term, that's equals to the arith term over the qth term. So we have already shown this here. So if we equate these two equations, then we can say that q minus r divided by p minus q, this is obtained from this particular equation, this must be equals to r minus s divided by q minus r. Or in simple terms, we have q minus r whole squared equals to p minus q times r minus s. And whenever this criterion is met, you can simply say that p minus q followed by q minus r and then r minus s, these three terms must be in a geometric progression. Hence proved.